Okay, in this problem, an observer is 1.4 miles from the launch pad of a rocket. The rocket is launched upward, as shown in the figure. So here's the rocket. It's launched upward. Part A says, write the height h in miles of the rocket as a function of the angle of elevation. So anytime you're asked to write a variable h in terms or as a function of another variable x, it means we want to write h as a formula in terms of x. H is some function of x. So if I look at what I'm given in the triangle, I know the angle is x, and h is the opposite side, and I know the adjacent side is 1.4 miles. So I think I can use a trig function to relate these three items. In fact, when you think opposite and adjacent, you usually associate that with tangent. So you could say tangent of x is equal to h, the opposite, divided by the adjacent, the TOA part of SOHCAHTOA. And then if I solve this for h, I'll have exactly what they want, h in terms of some formula or function of x. So if I multiply both sides by 1.4, I'll have it. Just get h by itself. And so I'll turn it around and say h is equal to 1.4 tangent x. But when you type it in WebAssign, make sure you put parentheses around the x. And then for the second part, they want the distance, d, in miles from the observer to the rocket as a function of the angle x. But if you look at this picture, the distance, okay, here's the observer, and so this is the distance we're talking about, d. And so that's the hypotenuse of this triangle formed here. And so we want d, we know the adjacent side. When you think about the adjacent side in reference to the angle x and the hypotenuse, most people would come up with the cosine function relating the two. So for part B, I would say this. So this is part A up here. For part B, I would say the cosine of x would be equal to the adjacent over the hypotenuse, which is d in this case. Now, if I solve for d, think of it like this. You could cross multiply, get d times the cosine of x is equal to 1 times 1.4, just 1.4. And then if you divide both sides by the cosine of x, you have it. You have d as a formula in terms of x. 1.4 divided by cosine x, which you could write as, okay, if you think about it, 1.4 over the cosine x is the same as 1.4 times 1 over the cosine x, which is this guy right here, is secant x. So a kind of a slick way of writing the answer then would be d equals 1.4 times secant x. Remember, when you type it in WebAssign, you'll need parentheses around the x. As for part C, in WebAssign, you're asked to graph both functions in the same viewing window. Well, they're referring to a graphing calculator, which you could use in this problem. But I claim I can figure out the answer without a graphing calculator. I know that the graph of the tangent function that we got in part A, h equals 1.4 tangent of x, I know that the tangent function goes through 0, 0, which immediately eliminates two of the possibilities. So neither graph goes through 0, 0 in the first possibility or the third possibility. So it's either this graph, the answer is either this graph or this graph. But then furthermore, I know that d equals 1.4 secant x, or 1.4 over the cosine of x. But the cosine of x is a height of 1 at 0. So you plug in 0, you'll get secant of 0 equals 1 also. So when you plug in 0 for x, you get 1.4. So d should be at a height of 1.4 at x equals 0. And this graph here would be the only one that satisfies that. So this graph would have to be the one for D. The one on top would have to be the one for D. And the one on bottom would have to be the one for H. And then once you realize that that graph is correct, then the answer in part D becomes obvious too. The graph of D is above the graph of H, as in this picture. This is D right here. However, the distance between the graphs approaches 0 as x approaches pi over 2, where the tangent is not defined. And you can see that happening. Both graphs approach each other as x goes to pi over 2.